So the next part of this problem asks us to prepare a stock solution. So what do we know for this? We are given 0.1 molar stock solution of anserine, okay, at pH equals 8.27. So that is our pKa2, which is here, 8.27. We just calculated that. And we're given 0.1 molar HCl solution and 0.1 molar NaOH, sodium hydroxide solution. Okay, we need to prepare a 0.04 molar anserine buffer solution at pH is equal to 7.2. So we have a 0.1 molar stock solution of anserine at pH 8.27, and we want a 0.04 molar solution of anserine at pH 7.2. So we're going to need to use one of our acid or base solutions to adjust the pH. So since we're at pH 8.27, we're going to need to use an HCl solution to adjust that pH. So let's first calculate how much of our stock solution we're going to need to start with. So if we have 0.1 molar anserine stock solution, okay, so we want 1 liter. Okay, let me write the equation down, right? So what's our dilution equation? So our dilution equation is M1 V1 equals M2 V2, right? So 1 liter times 0.04 molar, that was volume times molarity, I got that backwards, and that's what we want, is equal to M is equal to V2. I don't know why I wrote this down backwards. V2 times M2, which is 0.1 molar. That's the molarity of the stock solution we have. So we need to calculate how much of this stock solution we'll need to use. Okay, so 1 liter is equal, we could just put 1,000 milliliters here. Okay, and if we use milliliters, it won't really matter in this, and so we'll get milliliters out. So our V2 is equal to 400 milliliters. All right, but the pH of that stock solution is going to be at 8.27, okay? And so we need to titrate that to pH 7.2. So what are we going to use? We're going to use our 0.1 molar HCl. All right, so since we've got a buffer, we need to calculate how much of the, so what are we calculating here? We're calculating how much of this imidazole group we need to react with in order to get the pH that we need. Okay, so in this region of pH, we're going to be mostly reacting with this imidazole group, and our pKa of that group is equal to 7.04. Okay. So the pH that we want is 7.2. So let's write our Henderson-Hasselbalch equation down. pH is equal to the pKa plus the log of A minus over HA, or base over acid. So our base is the imidazole group, and our acid is the imidazole group with a hydrogen on it. Okay, so we can call that I and IH plus. So the pH that we want is 7.2, and the pKa of that group is 7.04 plus the log of I over IH. Okay, so we can solve for this ratio here, okay, this ratio. So I over IH plus is equal to 10 to the 7.2 minus 7.04, which is equal to 1.445. So now we know that I over IH plus is equal to 1.445. So don't forget that these guys are in concentration, and I'm going to just leave those brackets off for simplicity for a little while. Alright, so we know I over IH plus is equal to 1.445, so we can solve for I. I is equal to 1.445 times IH plus, okay? And we also know that I plus IH plus is equal to 0.04 molar, because that's the total concentration that we need. And so we know that if in solution we're going to have both of these things in solution, the imidazole group and the protonated imidazole group, to give us a 0.04 molar solution. So we can plug this I back in here. So we get 1.445 IH plus IH plus from this guy here is equal to 0.04 molar. Okay, so 2.445 times IH plus is equal to 0.04 molar. So IH plus at pH 7.2, because that's what we were solving for, is equal to 0.04 molar divided by 2.445 is equal to 0.0164 molar. So that's the amount of this imidazole group that we need to neutralize, that we need to react with the acid in order to get the pH that we want. Okay, so we can say 0.0164 moles per liter times 1 liter per 0.1 molar. That's the solution that we have. Okay, that's our HCl solution, and we need to react. We need this many equivalents of it times 1,000 milliliters, okay, is equal to 164 milliliters of our 0.1 molar HCl solution. So how would we prepare this buffer? We would take 400 milliliters of our anserine stock solution, but that's at pH 8.4, remember? So then we need to add 164 milliliters of the 0.1 molar HCl solution to bring us to a pH of 7.2. And then we're going to add water, distilled water, to total 1 liter. So what would we do? So if we were going to prepare this, we would get a volumetric flask out, okay, and it has a little mark here on it that gives you 1,000 milliliters. Okay, so first you're going to put in your 400 milliliters of your stock solution. Well, that didn't come out right. Going to put in your 400 milliliters of your 0.1 molar anserine stock solution, then 164 milliliters of your HCl solution. Okay, so it's going to be about right there. Then you fill it the rest of the way to the mark with water.